Okay, let's take a look at an example where we are solving a logarithmic equation, or an equation involving logarithms, but we have multiple logs, right? So step one is going to be to condense those logs, those multiple logs, into one, right? So in this case, we see here we have the addition of logs, and we've learned now that that is the same thing, right, as combining those into one log using multiplication. So we're going to do that to start off, right? Okay, so log 4, and then what do we have? We have x now times x minus 6. Okay, now sometimes there's a little bit more simplification that you can do. So in this case right here, we can actually go ahead and distribute. So I'm going to do that. All right, now where do we go from there? Well, at this point, we have one single log, right, that is equal to a number. So what we can do is we can apply our exponentiation rules, right? That's kind of like our math way of saying loop-de-loop. So what we could do is we could say, hey, we know 4 to this power must equal that, right? And so we're going to rewrite this log as an exponential expression. So 4 to the second power must equal x squared minus 6x. And so at this point now what you've done is you've gotten rid of the log out of the problem, and now we've created just kind of a basic algebraic equation. So simple stuff. Obviously we know 4 squared is 16. So we're going to just go ahead and do that, right? And then we can see this is starting to shape up as a quadratic. So we're going to move everything to one side, set it equal to 0. And then it turns out that this is factorable, right? So we can go ahead and factor that. So x minus 8, x plus 2, and so where does that lead us, right? We have two solutions. Okay, so x equals 8 is an option, x equals negative 2. Now, here's the issue that some people miss. So the algebra has given us two solutions. However, if we look at the context of the problem, come back in here, right? If we were to substitute 8 in for x, the resulting equation should work, right? So log 4 of x, just come over here and do it, all right? So log 4 of 8 plus log 4 of 8 minus 6, which is 2, should equal 2. Well, again, by properties, log 4 of 16 equals 2, and it does. 4 squared equals 16. However, right, so that's an answer. Here's where we run into a problem. If I try to do this with negative 2, right away I have a problem, because I'm writing log with a base of 4 of a negative number, which is impossible. So one of the things we have to watch out for when we solve logarithmic equations is what we call extraneous solutions. And negative 2 is an extraneous solution. So in this example, only 8 would be acceptable. Thanks for watching.